Okay, so welcome back. First ninja training exercise, and before we proceed, I I recommend you try the exercise on your own, but also watch the solutions video. So like, don't skip this lecture, because I'm gonna be showing you some nice visuals. I'm gonna be teaching you things as we as we do the solution. We will write up the solution. So please, even though if you do get it, don't skip these lectures. So, because there is important information. Anyway, let's go to task number 1. Starting with the 3 probability axioms, prove the following. If A is an event, then A conjugate, the probability of A conjugate equals 1 minus the probability of A. Okay, that's no trouble. So, let's go straight to the board and begin. So, first, let's draw a picture, a nice picture. And this is going to be our sample space. And let's say we have a set A. So here, this is A. And then outside, so the whole thing, so maybe I should say the whole thing is omega. And then outside is A conjugate, right? Now, A conjugate and A are disjoint. Remember? Disjoint means they don't overlap. So here you've got A, but A conjugate is everything that isn't A, right? So all we can do is we can say, if we have something like this, for example, we have omega, so everything, omega equals the union of A and A conjugate. Now, what we can do now is use the third axiom from probability. So let's see what that was. So where is the third axiom? Here. So it says if we have some union that are just disjoint, right? We can just sum the probabilities up. So okay, so the thing is, just this is a very, very technical point. This is infinite, so we don't have an infinite, we don't have an infinite number of sets here, but you can actually show that this can be n using more advanced proof. So this is called like the third probability axiom, and then you can, so this is like infinitely additive or whatever, and then you want to turn this into finite additivity, which means you sum up to a finite number of sets. Now I'm just going to say that's true. You can do it to a finite number of sets. You may be confused, like, Steve, what's the difference? If we have an infinite number, then of course we can go up to a finite number n or something like that. I'm like, if you continue with probability, you have to be very technical about these things, but we're not that technical here. So we'll just say we have these two sets and we'll use this axiom to prove what we wanted to prove. So we just take probabilities of each side, right? So the probability of omega equals the probability of A union, yep, A conjugate. Cool. So we keep going. We know this is 1. Remember this from axiom 2. The probability of omega is 1. Done. And so let's take it slow, So this is that. Yep, easy. Okay. Next, after that, we can, because these two here, they're disjoint, right? And what did I say about disjoint sets? You can separate them out into sums. So this thing here is just a fancy way of writing a sum. Okay, so just adding stuff up. Because they're disjoint, it means, and you can't do this when they're not disjoint, but because they are disjoint, we can write this. That's a P. It's probability measure. We can write this. Yep. And then we just take we just get this conjugate by the probability of the conjugate by itself. So that's just gonna be the probability of A conjugate equals 1 minus the probability of A. Cool. And that's what we wanted to prove. And so here are the solutions. I wrote that out, and so take a look at it, try it on your own. And next we're going to try task number, where is it? Task number 2, which is prove. We'll get to it when we get to it.